Yeah, I think yeah, we'll make it start now. Hi everyone, good afternoon everyone. So welcome to this SoPHE technical event. My name is Giovanni Tocco. I am the SoPHE UAE chair, and today technical presentation will be on Thermodynamic Solar System by Enernouva Energie GCC. Okay, so as you may know, CIBSE SoPHE Responsibility as a region is to promote the intellectual welfare of its members and improve the understanding of building services engineering within our society by organizing events and other activities related to the built environment. This is basically what we do and what we help to promote. SoPHE information can be accessed on CIBSE website. And if any one of you guys on the call need any information with regards to SoPHE membership, please do not hesitate to contact myself on giovanni.tocco@wsp.com. Also, any upcoming SoPHE event will be posted on the CIBSE UAE LinkedIn page. And I will also encourage all public health engineers to follow the SoPHE LinkedIn page for any general information and technical discussion in the society. All the relevant links are on the screen for your information. So coming back to the main event for today, so the technical presentation will be on Thermodynamic Solar System by Enernouva Energie GCC. The speaker is Mr. Hugo Domingues and Margarita. Session notes, please type your question on the Q&A panel that will be answered by the speaker during the Q&A session at the end of the presentation. So your camera will be off and mic will be mute. And on that note, I'll hand over to Margarita for a quick introduction. So Margarita, you can.
Okay. Hi. Hi. Hello, everyone. Good afternoon. So, hello. This is Margarita speaking. Thank you very much for inviting us to the call. In the next 45 minutes, we are going to present our technology, Thermodynamic Solar Energy System, and Hugo Domingues, who is the managing director of Enernouva and responsible of the brand of the Middle East. So he will now walk us through the details. So I will hand over now to Hugo. So Hugo, let's go.
Hi, everyone. It's a pleasure to be here and to present the technology to you guys. Thank you so much for inviting us. Presentation. Let me share now so we are here today to talk about thermodynamic solar systems. And you immediately see that our solar panels are different from the rest. They are black, made of aluminum, and they don't have any fragile materials. They don't have any rubber, any glass, anything that can be easily damaged. And you will see throughout this presentation why this system is much better than the traditional solar systems. This technology, although most of you don't know it, it was invented 32 years ago in Portugal. Since then, we enhanced the product, we start to export it. We are now in more than 50 countries all over the world. And in 2016, we came to Dubai to develop the hub for the Middle East. So thermodynamic solar systems are systems to produce hot water using the sun radiance, not the sunlight, and also the temperature of the elements, anything that we can take out of the environment. Like that, we can provide more hot water using less storage capacity, less space, less panels, all days of the year, no matter if it's sunny, cloudy, dusty, or even during night. What we require for our system to operate in a standalone mode is to have at least 0 degrees outside. So normally, I have this slide because normally in the GCC countries, the hot water is a little, let's say, undervalued. People take hot water as a given fact, and actually the water coming from the network, especially in summer, is quite high comparing with many other countries all over the world. But still, it's required to have the necessary hot water system to avoid problems like Legionella, or even for the simple fact to have comfort for everyone. In hotels, and this is DUA numbers, DUA is Dubai Electricity and Water Authority, 20% of the water in average, 20% of the water used in a hotel is hot water. And if the hotel is using electrical calorifiers in order to heat up the water, is using 12 to 15% of the total bill consumption. So it's still relevant to tackle this issue. So how does it work? So inside our solar panels, we are not using water like the traditional solar panels. We are using refrigerant fluid. And we use the fluid because it can absorb much more energy out of the environment as it boils at minus 43.6 degrees, rather than water that boils at 100 degrees. So the liquid, the refrigerant fluid, will go in liquid mode into the panels, and it enters the panels at around 50 degrees or minus 50 degrees, I mean. Then it will evaporate on the panel using the sun radiance and the heat coming out as vapor. Then it's pulled by a compressor that compresses the gas up to 28 bars, rising the temperature to 72 degrees. Then it goes to the heat exchanger. This is the main heat exchanger located on the supply tank, and we do the heat transfer to the water. After that, the remaining of the energy will go to a secondary heat exchanger located on a preheating tank, and then the fluid will go into the solar block where we have an expansion valve that reduces pressure and temperature, and it goes back into the panels in a closed loop. You never have to refill it because you are not spending the gas. You're just changing from liquid to vapor and the other way around, and from low pressure to high pressure and the other way around. As you can see, the system is an inverted refrigeration system. So the cycle will go on until the water meets the set point, which in a hotel is 60 degrees. Then it will stop and it will restart on delta T that you can choose. Then we have the hydraulic line, the cold water supply coming before the secondary heat exchanger, the hot water return coming after the secondary heat exchanger but still on the preheating tank, the preheated water, and then the supply water to the building. This is a schematic of one module, and we can scale the solution to whatever needs we want, as long as the temperature of the water don't increase more than 65 degrees. The same concept can be applied in villas and small restaurants, for example, but then we don't require to have two tanks. Okay, we have, for example, for a villa, we use only one panel, and the compressor, the thermodynamic unit, is integrated on the hot water tank, and the heat exchanger is wrapped around the tank. The same concept, only different gas. The previous system is using the 407C, and this system is using the R134A. So the main advantages comparing with the traditional solar system is, first of all, we are highly perform, so we can produce at least 66% more hot water per panel comparing with top European solar thermal panels. Then we don't overheat. This is one of the biggest problems in the GCC countries, when especially in summer with direct sunlight, the solar panels tend to lose performance and start to get damaged. Our panels can withstand 120 degrees, so they don't face that problem. Then we are fully protected from corrosion. In some areas here, the humidity is extremely high in summer, and also the proximity to the Gulf creates a very highly corrosive environment. Our panels, they are made of anodized aluminum with a certified marine coating that make them not vulnerable to corrosion. Then we don't need to clean our panels. This is very important. You know that the environment here is very dusty, and these panels, since they don't use the sunlight, they don't require to be cleaned. Only for image purposes, we can pass water on them if they are in plain sight of the guests or the residents. If you don't clean the traditional panels, of course, they are not meeting their performance. We tested this system in Masdar City over a year to confirm this claim. Then we have minimum maintenance. Actually, on the panels, we are maintenance free. We only need to do maintenance on the tanks, for example, to replace the magnesium anode that protects the tanks. or to check the pressures of the system. And this is the game changer. We require 80% less space. And how? We don't need, this panel doesn't need to respect the normal requirements of the solar panel. So a solar panel in this part of the world normally stays at 25 to 30 degrees inclination, and then it has to be facing south. Our panel can have any orientation, and it can be from 10 degrees to 90 degrees. Then you can stack the panels at least 30 centimeters apart, and you can have multiple levels on the panels because shade is not a problem. So like that, we can install up to 16 panels where you normally have space for one solar thermal panel, and each one of these panels can produce at least 66% more hot water than the normal ones. That's why we can retrofit full buildings like hotels. It's the only solar technology that allows to do that. Then we have a flexible installation. As you will see from the references I will show you later, we can install on rooftops, on facades, on walls, on parkings, and even on basements. Then we don't operate per sunlight, we operate per demand. So the traditional solar will try to get as much as it can out of the sunlight time. Let's say in this part of the world, we are quite lucky. We have 10 to 13 hours of sunlight per day. But then you need to get as much as you can. So you need to increase, for example, your storage capacity in order to have enough storage to last during night. In our case, we will only operate whenever there is demand. And for example, again, in the example of hospitality, we have demand during night. So we will be operating during that period. If for some reason the property that we have the system installed doesn't have demand during day, we will not operate during day. Then we have a very low running cost comparing with the traditional heat sources for hot water. So comparing with the electrical calorifiers, we are 90 to 92% less expensive on the operational cost. Comparing with boilers, diesel, synthetic natural gas, LPG, we are 80 to 85. And comparing with heat pumps and traditional solar, we are 35 to 40. And on the solar is because they are using electrical backup during night. Also, another advantage is the load. We can reduce the load of the buildings. One important feature about our system is on our biggest systems that we provide for residential towers, hotels, hospitals, staff accommodations. We monitor our performance, and we do it in a very transparent way because we install meters to measure the electrical consumption, the water flow, and the temperatures, and we share all this information in real time with our clients. They have a dashboard, and that allow them to see and to have more information and better data that will lead to a better energy efficiency system. At the same time, it gives transparency in terms of the relationship we have with the client, because you know, when we propose something to the client, it's based on real information, and they can actually see it when the system is operating. Okay, so from that point on, and I've been seeing on the properties, there's not a lot of meter related with hot water. The client or the department of engineering of the client will be able to monitor and react to the information that they get. Also, it allows us to get a better fine-tuning to the system, better maintenance, and to detect issues. So we have alarms. For example, if temperature goes under a certain threshold, we receive an alarm, we talk with the client. So the concept is that we can actually inform the client rather than the client informing us about any issue that can happen. I believe this is extremely important, and this is also an important tool for us and the client. Now some references, some examples that we have done in the GCC countries. This one is the Radisson Data Creek, the Radisson Blue Data Creek. It's a 5-star hotel in Dubai, in Data. Actually, it was the first 5-star hotel built in Dubai. Here we replace a diesel boiler. We install 80 solar thermodynamic panels using only 20 square meters of space. This shows you how we can play with the space. And we install it in this way because we wanted to use the collateral cooling. So our main target is actually doing hot water, but as any thermodynamic system, we have the cold side of it. And the cold side is that the panels are freezing. So they actually produce 1 kilowatt of cooling per panel. And we didn't want that to go to waste. So we discussed it with the engineering team, and then we install it. We create a special structure to install it in front of cooling towers. So these cooling towers are pulling the air to assist the water-based chillers, and then the air is passing through the freezing panels and dropping the temperature before entering to the cooling tower. So we are assisting the cooling tower and making the chiller much more efficient. To give you an idea, the temperature here between the panels and the cooling tower is less degrees than the ambient temperature. This system was a success. For example, the savings that we got on this property on the first 6 months were 160,000 dirhams. And we know this exactly because of the monitoring tool that I showed you previously. And this property won the retrofit project of the year for the MENA Green Building Awards. On this other property, still a Radisson Blue, this time in Abu Dhabi, Yas Island, we replaced a synthetic natural gas boiler. This was the first installation in a hotel done in our technology in UAE. You can see 120 panels installed in 3 levels. You can also see the ice on the panels. This was in August, where the temperature outside was 45 degrees. And this property reached the payback of this system after 2 years and 3 months, which is extremely good. Then here you have the Radisson Fujairah. So we are actually, since we have a lot of success in the other properties, we continue to do Radisson, and we have their trust, of course. Here we have multiple buildings. They had electrical calorifiers, and we replaced it for multiple thermodynamic units. Because we normally don't change the infrastructure, we adapt to existing infrastructure, so we don't interrupt the operation of the properties. We also try to set up the installation in a way that is nice to the eye, that will create some interest and some curiosity. Then we have the Enernouva de Palm. So the Enernouva de Palm is a completely different property, as they have villas and blocks of apartments. So again, the infrastructure was different, and we went building by building, so villa by villa. You can see here, this is a block of 8 luxurious apartments with only 4 panels. This was commissioned in July 2020. And we replaced electrical heaters. Then the Jumeirah Sadiat Island Resort. In this case, we went a little outside of the box. We installed it indoors without the sun radiance. So due to the architectural design of this property, there was no space that was given to us for the solar panels. So we worked with a consultant company, and we install it in a room on the parking, and we are absorbing the exhaust of the laundry to compensate the lack of radiance. So you can see this duct here is the exhaust of the laundry. Instead of going outside and wasting the energy, that it's being absorbed by our panels and put into the water. Here we replace a synthetic natural gas boiler. Then another property we install on the basement is the Fairmont Ajman. We use only 2 parking spaces, and we install it next to the pump room. We replace a diesel boiler in this case. This one is a clinic in Sustainable City. So we install it outdoors, but on the facade, 2 meters from the main door. Since it's Sustainable City, they agreed in this setup. And I think it's important that we show the users, the visitors, that the properties are using renewable energy and taking care of the environment. This one is the Danat Al Emirat Hospital in Abu Dhabi. Again, we use the facade of the service block, 0 ground space, to produce all the necessary hot water for the hospital. We replace a diesel boiler in this case. Then we also did residential towers. These ones are in Dubai land. You can see the type of installation. We replace individual water heaters. So here, this property had issues regarding the maximum load used. They had in each apartment 2 or 3 electrical water heaters, and then we centralized the property and connected to one central hot water source. Then we did multiple staff accommodation, some of them for Dubai municipality, as this one's on the top, and other properties and companies throughout UAE. Then villas, we have villas in all the GCC. Some of them here, for example, the Eco Villa in Masdar City. We have it also, this one is a property, Anantara Qasr Al Sarab, for example. We have here one in Jumeirah, near to the Burj Al Arab. Also properties in the Whirl Islands. And this one here is a swimming pool. So on the thermodynamic system, since we can only produce heating and not cooling, we only install these systems in indoor pools that require only heating. This one is in Riyadh. It was done for the NG and Tarshid. So here are some of our references, some of the properties we are working at the moment. And basically, that's it. So right now, if anyone has any questions.
Thanks, Hugo. Thank you very much. Very good presentation. There's a few questions I can see on the Q&A panel.
Let me go there.
I think it's one of them. What is the difference between your system and an air source heat pump?
So our system, as you can see, is a hybrid system. You can say that it's a hybrid between a solar thermal system and a heat pump system. So in this case, we can combine the advantages, because you can say that the solar thermal panels, they can only operate during the sunlight, but the heat pumps, in my opinion, are even better than solar thermal panels. They operate even 24 hours, but they cannot use the sun radiance. So by this thermodynamic solar is actually a combination of the two. And comparing directly with the air-to-water heat pumps, we are more performant, we consume less, and we last longer. And these are the 3 major points. So we produce more because we use the sun radiance, and our surface, our evaporator is actually our panel. So we have a much bigger evaporation area, so we can produce much more, let's say we can have a much better COP. Then since we don't have moving parts, we don't have any fan, any extra cycles, we can consume less. So we can have a better performance or COP than any heat pump in the world. Also, in terms of lifespan, heat pumps suffer a lot in UAE due to the dust and the humidity that goes inside the evaporator and requires a lot of maintenance. In our evaporator, since it's fully protected, and therefore it's not vulnerable, so it will last much longer.
Okay, see another one. What is the difference? What about compressor and refrigerators refilling? What's about compressor and refrigerator refilling?
So the compressor that we use on the big units is a Copland scroll compressor, and on the small units we use either a Danfoss or Hitachi.
Okay. Another question, what's the cost of structure of uplift to secure these to the facade of a building? I think that's
Sorry,
the
the cost of the structure.
Yeah.
So all we made are tailor-made. So we work with the client. First, we find the correct space. Then we have a team that works on the drawings, and we have a factory that produces the structure for us. So they have to be tailor-made to be adjusted to the reality. If you are working in a facade, there are more challenges, of course. But for example, the installation will be more costly. Of course, it requires cranes, boom lifts, and also the maintenance has to be taken in consideration. So the only thing that can be there on the facade is actually the panels itself, and the connection should be inside in case we require to do any maintenance.
Okay, next one. Is there any refrigerant leak detection system is available with the system?
Okay, so we are very thorough in terms of installation. So we do nitrogen charge for more than 1 day per module to assure, and we do it at double of the working pressure to assure that there is no leakage whatsoever. And then we do a proper suction with a lot of time as well to avoid any humidity inside the system. The humidity for this kind of any kind of refrigeration system is extremely bad. In case something out of the normal will happen, let's say any negligence will be there or some pipe will be broken, we have our own detection system, leak detection system, and we will detect and repair immediately. We have teams on the field to work on that. But due to normal operation, leakage will not happen.
Okay, good one. What about energy heat pumps compared to the thermal panel system for space constraint applications?
You said energy heat pumps?
Yes.
Well, again, regarding heat pumps are normally used for swimming pool applications, as we require heating and cooling throughout the year. So the heat pump can reverse the cycle, and it's very useful for that. For domestic hot water, is not used very often, and as I said, it's less efficient in terms of space. It depends. It's actually you can consider that air to water heat pump might require a little less space, but slightly. But the advantages, since we can be so creative in terms of locations, they surpass this issue. In terms of water-to-water heat pumps, they are massive. They are big, and they have a very low efficiency in terms of heating. They are actually better for cooling, and they are used sometimes to use let's say wasted heat.
Okay, next one. What's the comparison of the thermal panel with evacuated tube system?
Sorry, come again. Do you mind repeating?
It's a comparison between evacuated tube solar thermal and your system. Which one is better?
Well, as I said before, I consider evacuated tubes and flat panels to be the traditional solar panels. Okay. I actually all the points I compared with regarding the operation, the lifespan, the corrosion, the cleaning, everything was compared with those two. I'm not even comparing with thermosiphons. Thermosiphons is an old technology. So I did all this analysis, and this presentation is towards the vacuum tubes and the solar thermal flat panels.
Okay, next one is, can the panel integrate with normal aircon DX system, and improve aircon compressor efficiency?
Sorry, you want to the question is to incorporate this in a refrigeration system. DX, that's it.
Yeah, can the panel be integrated with normal aircon DX unit to improve the compressor efficiency?
So see, what first of all, we are always trying to develop. We have a very strong development team in the factory that is always trying to improve the product, to enhance the performance, and to be updated in terms of all the regulations in the world. That being said, the panel can, and we are trying here, as you saw, for example, in the Radisson data project, to use the collateral cooling that can be used in many applications. It can be used in cooling towers. It can be used in fresh air intakes, for example, but it's always in a collateral way. So it's not integrated yet into refrigeration systems, or as it was suggested before, to cool the water, for example, to use the panel to cool the water. These are all good ideas, and the product, of course, is being developed, but at the moment, the only possibility is using the collateral cooling.
Okay, it looks like, does it have electrical backup if all stored water was used due to peak demand and it's nighttime?
Okay, when we size the system, we size it in winter conditions, and we size it according to the consumer behavior. Let's say we have a hotel, we have 2 peaks a day. We consider it for full demand, winter conditions at night. That's the concept. Anyway, if you are in a hospital or in a hotel, and you always require to have an emergency backup. So that's a little different. Is that if something goes wrong or if there is some abnormal consumption, then you can turn on, or automatically it will turn on the emergency heater, so the guests will not feel it. But the concept is never to use it, as emergent heaters are probably the most inefficient way of heating water.
Yeah, but I suggest that you need at least an electrical heater if you have a centralized hot water system. With regards to pasteurization, at least you need to have a backup.
Yeah, again,
electrical element.
All the systems they have, even the vanilla ones that we actually produce for all the world. So in some countries, what I'm saying here doesn't apply. So let's say Northern Europe, you need the electrical backup to kick in a couple of months per year, as the temperature will drop from 0. But we always take that in consideration. Any backup we can put there. We can have an extra coil to the system and connect it with a boiler if there is the air boiler. And sometimes, it's not possible to take boilers out of the pump rooms. There is only by cutting it you can remove it. So we understand, and we actually do it. Always there must be a backup there, but we try our best never to be used, and that's on the sizing part. To do the proper sizing is extremely important.
Understood. Yeah, I think this answered the question from Youssef, I guess. Let me see. I think there's no more question. Is there any more question, guys? I think we pretty much kind of answered everything so far.
Just I have here Youssef that says that the system will operate at night. Yes, so we are using also the heat of the environment. So if it's more than 0 degrees, we are operating and give at up. And we do that because, as I explained in the beginning, the boiling point of for example, the R407C, it's 46.3. So it starts boiling at that point, and we know that at 0 degrees, all the gas will be completely evaporated. And as you know, the compressor, the scroll compressor, cannot take liquids. So we have a pressure stat that protects the compressor. So if any liquid will come, the compressor will switch off. That's why we have the limitation of the 0 degrees. Actually, we have examples. It is minus, let's say -2, 3, up to 5. If it's sunlight, it can still evaporate fully, but at night it will go to 0. It's like for us 0 degrees is very low and very cold, but for the gas itself it's actually very hot due to the properties. So I don't know if there is any more questions, guys. We still
have a few minutes left. So we still have a few minutes left. So if you guys have any question, just type it through the Q&A.
At the moment,
sorry, I'm having some network issue, I think. Okay, can you hear me okay, Margarita?
Yes, I can hear.
I think we lost Hugo.
Any more questions? No.
Yeah,
I'm here. I can hear you.
Okay, good.
Well, I have Yusuf here asking the temperature. So on the big systems, we can reach to 62 degrees. We also have a system that we call it the high temperature, a system that can reach up to 65. On the domestic units, we have our systems reach 55. And then we have an immersion heater inside. In case of disinfection, for example, we can just just click on the disinfection mode and it will take it to 65, but it will operate normally at 55. At what source temperature? So here in the GCC countries, the source temperature is actually very generous. We can have from 25 degrees in winter in Dubai. For example, in Riyadh, you can have 20 degrees. And for example, in Pakistan, you can get, in the north of Pakistan, you can get 10, 12 degrees on water. So the only thing, the system has a certain thermal power adjusted to the location. So if you have to do a bigger delta T, according to the thermal power, you will take longer or less time to reach it. That's the only point. The source, let's say the temperature at the source will impact the timing, but not the operation itself.
Okay, got another question. The system is completely depends on atmospheric temperature, no relationship with solar irradiation.
No, actually, the sun radiation, and that's why the panel is also black. Sun radiation increases the performance of the system, so it gives more thermal power into the system. So it helps. That's why we have, when we calculate our COPs, we calculate for during sunlight and during night, because there is a difference in output.
Okay. Good question. How much does it cost per panel?
So it's not really per panel. This is like per modules. So the system. So just one example: one villa of 5 bedrooms require only one panel for the complete hot water, and one tank, 250, 300 liters. That will be enough. The cost will vary, but I would say rule of thumb, with installation, it would cost 12,000 dirhams, 13,000 dirhams. That's not per panel, it's the full system with installation, with everything, the full service. But of course, then we need to see with the network exactly the prices. This is just a benchmark. For the big systems, again, it depends on the site conditions. It's much more difficult to say because what is the structure, what is the installation, what works have to be done. Do we need to act on the pumps, on the pipes? It needs additional accessories. So many things can be there. The only thing I can say is that we are more competitive than boilers, for example, which is actually our competition in the market for large volumes. And for villas, if you are comparing with a good quality solar system, since it requires more panels and more storage, we are competitive.
And you can simply play with the configuration of the panel as well, just to cater for the space constraint, you know.
Exactly.
Which is very interesting.
I have here some more questions. Let me see. Sorry, I lost it.
Yeah, this question.
Help me here. In summer, when the source temperature is really high. Well, when the temperature is really high, so let's say again in Dubai, 40 inlet temperature will create a lower faster. Of course, the impact of the heat exchanger in a higher temperature will decrease the COP. So actually, we have a better COP in winter but that happens in any heat source. So let me see. Hotel of 20 beds. So see, normally it depends as per our experience, and since we are monitoring many hotels, it will depend on the type of the hotel, how many stars. So that will tell you the behavior, also the type of, if it's a city hotel, if it is a resort. There are many factors, but I would say that a hotel, four-star hotel will be between 55 and 60 liters per guest, but then the number of guests will vary according to the type of the hotel. So then we have to size the system. We need to understand other points, not only the guests, also the number of outlets that are using the hot water. Also, we need to understand the hot water return line and the return pump that will also require power to reheat the water. So it's not easy to give you a straight answer about that. We need to analyze it case by case. So a payback in a hotel normally is between 2 years and 2 years and a half. The replacement of boiler or electrical systems. Only, for example, when the tariff is too low, give you the example, Abu Dhabi has a lower tariff than Dubai, it's less than half, then the payback will increase to 3 years and a half. And for example, when you are in Kuwait and the tariff is 5 fils per kilowatt hour, that in that case the payback is enormous. It will depend on each market, and of course the market will only change when the tariffs are normal and it makes sense financially. It says here if the panel is scratched. So the coating is flexible. So actually, if you throw a ball to it, it might bend, but it will not break, and the panel will continue in operation. So only really a perforation on the panel, on the void. So you see the panel. The panel it looks like it has piping inside, but it doesn't. It has voids. It's 2 sheets of aluminium with the space to pass the refrigerant. So only if there is a perforation on that area will actually be damaged, but it takes a lot to do it. The panels are certified, yes. They have Solar Key Mark. They also have the EM in Dubai. They have Dubai Central Laboratory approval. They have multiple certification all over the world, both the panels and the system. We have the MCS for England, NF for France, Watermark for Australia. We have UL and many more. So I think I've answered all the questions, not sure.
One more, what about lead points?
So lead points, so lead takes in consideration multiple energy, let's say efficiency systems, and solar panels are one of them. That happens also, for example, in the Estilama. And so yes, it allows to increase the lead points by using, not because it's thermodynamic solar, but because of the efficiency that we create using solar technology. Yes, our refrigerant, it's every 5 to 10 years there is changes in the refrigerant. There were refrigerants taken out of the market, and that's ever evolving all the countries in the world. So compression ratios in high and low ambient. So you mean at what pressure is running the low side and high side, or I don't know exactly. Anyway, I will answer like that. The low pressure side is running 3 to 4 bar. That's what is passing through the panels. The high pressure side will run from 22 to a maximum of 28 bar. So regarding the presentation, the slides, I don't know, Giovanni, are you sharing with the attendees the presentation?
Yeah, I mean, if that's okay for you, just drop me a copy of the PDF files, and I can share it to whoever want a copy. No problem.
Also, if you guys send us an email, we can also answer about that. I put the email on the presentation. Just a sec, quickly. It's here, info@energiegcc.com. So any questions that you might have, if you want to send it, we'll be happy to answer and support you.
Great, thank you very much, Hugo. That was a very good presentation. If I may take the screen back for a second, I think we got a good recommendation as well. It looks like the panel has already been.
I just want to thank everyone to attend this presentation. It was a pleasure to be here. I also see here that Kifa has an egg of 250, so it's a system of ours. So thank you for the recommendation, Kifa.
Yeah, I was about to say so. So you're already installed in Lebanon, which is good.
Yeah, we also have we also install some units in Lebanon. Yes. So great. Yeah, thank you so much for inviting me. It was a pleasure. I hope this was interesting for everybody.
Yes, thank you very much. It's been very productive, I hope, for everyone. Very good presentation. Thank you very much again, Hugo and Margarita.
Thank you. Have a nice weekend.
Thank you.
Yeah, if I may share my screen again for 1 second, it looks like there was a couple of questions on heat pumps. So the next event will be on heat pumps for domestic hot water generation, and that will be presented by Visman, which will be in end of Feb, and I'll keep you guys posted on that. So I think hopefully most of you guys can jump on the call. So that's it really. Thank you very much everyone for attending this presentation and supporting SoPHE and CIBSE. So we'll keep on doing the stuff on a monthly basis. So thank you again very much. Thanks Hugo. Thanks Margarita. Thanks everyone.
Thank you very much, guys. Have a very good weekend. It was a pleasure.
Yes, thank you.